So microservices right now are all the rage, and we want to talk about things like creating these nice architectures where we have services that are interacting with one another in different ways. 10 years back, it was the service-oriented architecture. Today, it's microservices. And there's some really fundamental distinctions between them, which unfortunately are probably too deep to get into in the middle of this presentation on Azure. But I do want to talk a bit about microservices and different ways to architect, because they potentially inform two technologies that I'd like to talk about that are very interesting and hosted there on Azure. So what are microservices? If you take a look at the slide and you look at the right-hand side of the slide, you see the traditional app. You have web calling into business logic and data, and you've got that whole communication protocol that requests come in on the web, then go through business logic, then through data, and all of these things. And the business logic might have order management and reporting and all of those types of things. Microservices are individually built and deployed, so if you look at that right-hand side, we're going to encapsulate things potentially in far different ways. Now, this encapsulation on the right-hand side may not be fully appropriate when you look at this. You might not encapsulate the HTTP listener and encapsulate page content. The idea is you're going to group things together in ways that make sense. And microservices traditionally follow things like domain-driven design, and they're a reflection of your actual business domain that kind of come up from the way that you do business in your work. Now, couple things with microservices. They're individually built and deployed. They're versioned independently. They tend to be deployed independently. They can scale independently. They react independently. They're small services, small being a word that's argued a lot in the microservices community. I've heard people say small meaning very small, just one responsible piece of stuff that gets done. Other people say small as something that one development team can manage on their own. Depends on, again, your domain and your architecture. But some of the ideas behind microservices that I think are critical are the microservices should be responsible for their own data. They should be responsible for their own state. They should be independent of all of the other parts of the application. And then we just coordinate those independent parts to work together. Why this talk on microservices? Because there's two things that happen to do microservices very nicely. And one of those is called the service fabric. And the second are containers, which are widely used in the open source community to handle microservices. Let's first go and talk about microservices running on service fabric. So the service fabric itself is used to manage microservices, but at scale. It is 24/7 service availability. We can create stateful services. We can run them in containers if we want. We can Dockerize all these things. They can run across Azure, AWS, on-premises. I don't care. You can run them on any machine, anywhere. The idea behind Azure Service Fabric is that we want to handle these microservices, or in some cases an actor model. Are there two main areas, but there's also just generic apps as well, that we really need global availability, high scalability, 24/7 uptime, really cost efficient, can scale up and can scale down on demand, and is managed effectively. And that's where the service fabric comes in. And the service fabric is a beautiful piece of work in that you deploy up into the service fabric and then gradually update your microservices, and the update process goes through that platform as a service engine where it will smartly and carefully upgrade you across all of your microservices, or actor models or other things. Now, microservices, I want to talk one thing. If you have two versions of a microservices, how do they run side by side if I just said that you require data to be embedded in that microservice, or it maintains its own state? They do it brilliantly with Service Fabric. You maintain a contract, basically, that says version 1 of your microservice can write to this particular data store, and version 2 can also write to that same data store. So you've got both of them at the same time can run it. That way, when you're spinning it up, you may have several microservices running, handling requests of one type that's writing to the data store, and it's spinning up and promoting new ones. Now, as you're upgrading from version 1 to version 2, the Service Fabric is smart enough that it can look at the performance and the characteristics and the safety of that execution of version 2 and say, ooh, this is failing too often. It doesn't have the same performance characteristics, etc. It will stop the upgrade, take the version 2 ones out, and leave you with version 1. Then you can go in and figure out what went wrong. So there's some really neat things that the Service Fabric does for you to help you with microservices and to help you with the Docker container. Now, and the microservices and the Actor framework. Couple things. Service Fabric just recently launched last year as a full functioning thing in Azure, available for public consumption. And a lot of people say, well, it's kind of new. It is not new, and that's the interesting thing. This is what DocDB, SQLDB, Skype, most of those big software as a service platforms that Microsoft provides to you as a consumer, they're hosted on the Service Fabric. So Microsoft has had many, many years of development, 7 or so years on the Service Fabric, that they've been continuously iterating and making it better and better and better. What they've done is they've just made the Service Fabric available in a commercial format so that we, as consumers of Azure, can use it to build our own infinitely scalable 24/7 type applications. Whew. I think that's enough on Service Fabric. I'm going to turn it over to you for a little bit to talk about containers.
Yes. So Steve mentioned that there's 2 main ways that you can do microservices in Azure, and he went over Service Fabric. The other one I want to chat about is Azure Container Services. So before we get to that, I want to just give a quick recap on what containers are. So I don't remember the last time I actually installed an operating system on a physical machine. I don't know if you remember, Steve. It's been many years. But 10 to 15 years ago, if you wanted a new service, you had to stand up a machine and you had to order a physical machine. You put the disk in and you'd install the operating system and so on. And of course, we went through a virtualization revolution where instead of working with physical machines, we realized, well, we can much better use those resources if we virtualize. And so we're now so used to doing virtual machines because we can get a whole lot more density of the physical hardware.
But they're big. I can't run on my laptop more than a few core virtual machines. I just can't do it. I don't have the memory.
Right. So that's where containers is the next logical step in that evolution. What if we could virtualize not just the machine, but what if we could virtualize the operating system as well? Yeah. And so now you get these things called containers, which allow you to do exactly that. So I predict, this is part of my prediction for the future, is that in a couple of years we'll look back and we'll say, when was the last time you spun up a virtual machine? And we'll all have a chuckle because everything will run in containers. So I think this is definitely something which is going to continue to gain momentum and popularity. And so if you've heard of Docker, then you've heard about containers because Docker made containers famous. It's not the only way of doing containers, but they're definitely one of the famous players in this space. So the containers act as fully isolated and independent operating systems, and they're ideal for iterative app development and testing. So one of the things that you'll do once you've actually got a container out is you want to be able to run it somewhere, right? And so you will need some kind of infrastructure to run that container. And so this is where you could spin up your own data center to start serving your containers and running your containers. But if you've been around this video recording for any length of time, you'll know that we frown upon spinning up your own data center because Azure will do this for you. And so there's a service called Azure Container Services, which will allow you to spin up containers in a pool of resources, which you get to define. And that pool of resources, you can think of it as a single giant machine. Yes, there's a number of machines under the hood, but for your purposes, you really see it as a single group of resources, a single 1 terabyte of RAM and 14 billion terabytes of space. It takes all those nodes in that cluster and essentially aggregates them so that they look like a single machine. And when you deploy your containers into the container service, it will spread them out according to which nodes are performing, which nodes are up. When nodes go down, it'll move them over to other nodes. It's sort of self-healing and so on. So I do want to mention at this point that you can run a container just on a single host. So you can spin up a virtual machine in Azure and it can run some containers. But if you want to start taking containers to the point where they're scalable and where you're wanting to run them over more than a single machine, this is where you would need something like Azure Container Services. Now, Azure Container Services introduces something called orchestration, and that's where tools like Mesosphere and Docker Swarm come into play. These are software applications that can orchestrate across multiple nodes, and they can take containers and move these containers across different nodes in the underlying pool. And so Azure Container Services lets you spin these up, manage the containers, see what's going on inside the cluster so that you can see if there's particular machines that are not performing or if there's particular containers that are experiencing load, so you can scale them up and down. And it allows you to configure things like load balancing, right? You might have 5 or 10 different web services that are running inside containers. You want to load balance those so that they're seen as a single app from the outside world. And so these services come part of this orchestration software that's running for you inside of Azure. So if you take a look at the slide, I'm going to summarize here with some of the things you can do with containers. So Azure does support Docker for Azure VMs, so you can spin up either a Windows or a Linux VM and run your containers inside the VMs. Then you want to go to container-based PaaS, where you're wanting to say, I've got a cluster of nodes and I want to run containers in that cluster. Well, you can do that using Service Fabric, OpenShift, Cloud Foundry. Azure Container Service itself gives you DCOS, DCOS, and Docker Swarm, which will do that orchestration stuff. So you can offload the orchestration to the infrastructure there. And of course, container management, being able to manage all of these containers that you spin up. You might spin up hundreds or thousands of containers, and you want to have some tools to manage that infrastructure, and things like Kubernetes and Docker Swarm and DCOS fall into that place, and they're all available on the Docker service or on the Azure Container Services.
It might have been a little unfair. When we started this discussion, I started it with microservices. And I often see Docker and Play and containers in microservices and in Service Fabric. But to be fully transparent, they're both used for bigger things, for other things other than microservices as well. And you'll find containers everywhere, even in places that aren't microservices.
Right.
So they're very powerful tools, but that good introduction to get with microservices. Can I throw in one more thing?
Go ahead.
I mentioned that I think there were 2 good ones. We could use the Service Fabric and containers for hosting your microservices. There's another that's commonly used as well, and that's Azure Functions,
Right.
because those can be completely independent of everything else and kind of run in isolation. And those also make a great framework to host your microservices as well. Sorry, back to you
Right.
for that little interlude.
Thank you. At this point, I think I want to show you what it looks like to spin up an instance of Azure Container Services, so we'll jump into that demo.